So here's another question. In the circuit below, the voltmeter reading is 0. When the temperature of the thermistor T is increased, the voltmeter reading changes. Which change in the circuit will restore the voltmeter to 0? Is it A, a reduction in the EMF of the cell, B, a reduction in the resistance of P, C, an increase in resistance Q, or D, a reduction in the resistance of R? Well, the resistance of T decreases with an increasing temperature. That's an NTC thermistor. So the only way to get the voltage back to 0 is if I drop resistance Q, drop resistance R, or increase resistance P. The only option there is D then. You have to reduce the resistance R. So how do I get that? Well, I think it's best explained with actual numbers. So if we pretend that the cell has a 3-volt EMF, if we pretend P is 10 ohms and Q is 5 ohms and R is 10 ohms and T is 5 ohms originally. So now if we can imagine Coulomb's worth of charge pops out of the cell with 3 joules of energy at that point, it would have to drop 2/3 of its energy after P, because that's where 2/3 of the resistance is, and it would end up with 1 joule top of the voltmeter. Equally, another Coulomb can pop out with 3 joules of energy at that point, and because the resistance ratios are the same, it would also end up with 1 joule of energy at the bottom of that voltmeter. So the difference in energy is 1 joule minus 1 joule. So that's 0 joules. So that's 0 joules for each Coulomb. In other words, 0 volts. That's the original situation. Now, what happens if I were to drop the resistance at T? It's currently 5 ohms, but let's change the resistance to something lower, like 1 ohm. What would I need to do now to R to keep the ratios 2-to-1 type ratio? Well, I would need to drop the resistance R down to 2 ohms, and then I've got that 2/3, 1/3 scenario again. And that would keep the voltmeter reading 0 volts.